All around us, right this very second, there's this invisible world just humming with information. We're sending messages through thin air constantly. And today, we're going to pull back the curtain and see how this incredible invisible network actually works.
I mean, think about it for a second. You pull out your phone, you tap one little button, and bam, you're connected to the entire world. It feels like total magic, right? But what's really going on in that split second?
Well, it's not magic. It's just really, really cool science. Every single time you connect to Wi-Fi, you're broadcasting and receiving data using radio waves. Yep, the same basic tech that's been around for over a century, just supercharged for our digital lives.
Okay, so to really get how this all works, we first need to look at the basic blueprint. What are the essential building blocks that make any of this wireless communication even possible?
At its core, a network is just a bunch of connected devices that can talk to each other and share stuff. It's kind of like a digital neighborhood, Every house can send messages to every other house on the block. So in this digital neighborhood, each house is what we call a node. Now, node sounds super technical, but it's just a fancy word for any device on the network. Your phone? That's a node. Your laptop? A node. Even that smart printer you have? Yep, that's a node too. And of course, you need a way for all these nodes to actually talk to each other. That's the link. Now, in a wired network, that link is easy to see. It's the Ethernet cable. But for us, the link isn't a physical thing at all. It's the air itself. And what's so cool is how this simple blueprint just scales up like crazy. It starts small with the local area network, your WALN, in your home or office. Then it gets bigger, connecting whole cities in a MAN. And finally, it goes global with the wide area networks, the WANS, that power our cell phones. It's all the same idea, nodes and links, just on a totally different level.
All right, so we've got the blueprint down. Now let's get to the fun part, the engine. How do our devices actually send messages through the air? How do they talk using these invisible radio waves?
It's a surprisingly elegant little four-step dance. First, a transmitter, say your router, cooks up a data signal. Then its antenna converts that electrical signal into radio waves and sends them out. Those waves travel through the air until, step 4, your laptop's antenna catches them and its receiver converts them right back into data you can use. So it's convert, send, catch, convert. Simple as that.
So here's the absolute key difference you need to understand. A wired network is what we call a bounded medium. Think of it like a highway with clear paved lanes. The data has a set path, it can only go where the cable goes. Super reliable, but pretty restrictive. But a wireless network, that's an unbounded medium. It's more like sending a message in a bottle across a wide open ocean. It gives you incredible flexibility, but, well, it also comes with its own unique set of challenges.
And that whole open ocean idea brings us to the rules of the air. Because when everybody is trying to shout their message across the ocean at the same time, things can get pretty chaotic. This is where we get into those all too familiar frustrations with our Wi-Fi.
I mean, we've all been there, right? You're trying to stream a movie or jump on a video call and everything just grinds to a halt. In this amazing wireless world, why does that still happen?
Well, it usually comes down to two big culprits. First, interference. Imagine you're in a super crowded room and everyone is shouting at once. It's impossible to have a clear conversation, right? That's basically a radio frequency traffic jam. The second big reason is something called shared airtime, or half-duplex. See, most wireless devices are like walkie-talkies. They can either talk or listen, but they can't do both at the same time, over and out. That's a huge difference from a wired connection, which is more like a phone call where you can both talk at once. All that switching back and forth on wireless, it really slows things down. So to manage all this potential chaos, we have rules, or protocols, and the most basic one is the SSID, the Service Set Identifier. You already know this one, even if you don't know the name. It's just the name of your Wi-Fi network. A really simple way to think about it is this. The SSID is just the name of the party you're trying to join. It makes sure your device connects to the right conversation and doesn't just crash someone else's. But, getting to the right party is only half the battle. How do you make sure your conversation stays private? That's where encryption comes in. It's like a digital lock that scrambles all your data while it's flying through the air, making it total gibberish to anyone who doesn't have the key. This is absolutely crucial for keeping your information safe.
So we've gone through the blueprint, the engine, and the rules of the air. But why does any of this technical stuff actually matter to you? Well, because this invisible system is, without a doubt, the foundation of our modern world. I mean,
These principles have given us advantages that we totally take for granted now. The mobility to work from literally anywhere, the convenience of a space that isn't cluttered with a million cables, the ability to set up a network in places where running wires would be impossible, and of course, sharing printers and files without having to plug anything in. It has completely changed how we live and work.
And this is so much bigger than just the Wi-Fi in your house. The exact same ideas we just talked about, they power our global mobile phone networks, our satellite communications, and even huge networks of wireless sensors that monitor everything from weather to traffic.
When you step back and look at the big picture, our entire modern world, from how we talk to our families to how global economies run, is built on top of this carefully managed, totally invisible infrastructure.
Which leaves us with one last kind of mind-bending question. We've conquered the physical limits of cables, but the radio spectrum, the air that our data travels through, that's a finite resource. As we keep connecting billions and billions more devices, what happens when we start to run out of air? What comes next?